I'm a professional Unity nerd basically, and I spend my time creating technical demos, workshops, talks, and lots more to help teach all of you the latest Unity tools, workflows, and really in return, I also listen to what you all are creating. What do you care about? What are your challenges? And I take that feedback and I bring it back to our internal teams at Unity so we can make the engine better for you and your creations. Now, I've been in the games industry for about 10-ish years now, working at places like Games for Change, Global Game Jam, Indiecade, and now Unity, of course. And my focus throughout all my projects and all the places I've worked has been about democratizing game development. How can we make development more accessible to more different kinds of creators out there in the world? So that's why I'm very excited to talk to you today about Unity visual scripting. Now that this is a feature available in the editor, I know it's going to open so many different doors for folks of all backgrounds to create games and apps in Unity. And I know this because it happened to me. When I first discovered game development as a career, I was already, well off on my way to become a zoologist of all things. I discovered development and programming, and I wanted to learn more. So I decided to learn how to code, and I had a really hard time at first. It was a bit of a struggle, to be honest. So then I started using visual scripting tools from that time, like Alice and Construct, so I could actually try something that I thought maybe might work better for my brain. And it really did. Visual scripting helped so many aspects of development click for me. And I was able to understand, create a bunch of my own games, and that eventually led me to become the Unity game developer that I am today. So, really, I hope this session can help you or somebody that you know also find similar opportunities through something like Unity visual scripting. Now, but let me start with defining it for those of you who have never heard about it before. And if you have heard about visual scripting, I'd love to know if folks here in the audience have any experience with it. Have you used Unity visual scripting? Have you used similar tools, maybe like Scratch? Let me know in the chat. That context would be really helpful for this talk. But if it's your first time hearing about this feature, really what you should know is that visual scripting in Unity is a way to design powerful interactive behaviors in a way that's accessible to all creators. You can create logic by connecting these visual drag and drop nodes instead of writing traditional code by hand. And what's nice about visual scripting in Unity is that you can make a game or application completely with visual scripting, or just like you can make a game completely with C sharp, right? Or you could use both together. There's a lot of flexibility. Use whatever feels right to you. If you know how to code and you want to code in C sharp, you can do that. If you want a different way to approach coding, visual scripting could be right for you. Let's find out. So I want to start out with a brief example to show you how visual scripting can work. I have this key here on the screen and I want to make it rotate. And I can do that by using 3 visual scripting nodes. First, I need an update node that will tell my game to execute logic at every frame of the game. Then I need a rotate node, which tells my key object to start rotating. And then I need to take a float node with a value of 1, attach that to the rotate node to the Z angle value. And what that does is that it tells the rotate node to rotate my key 1 degree across the Z axis every update of my game. So very brief example. I'm going to jump into some more complex examples shortly. But let me go ahead and talk about when, how, where would you use visual scripting? Now, whether you're a solo developer or you're working with a team, this all applies. Really off the bat, I have to say that Unity visual scripting is such an excellent tool for rapid prototyping and testing. Say you're a game designer and you are wanting to test out some logic for a game mechanic. Or maybe you're an animator and you want to see how your work looks in the editor. Instead of having to spend your time like writing out and researching a bunch of complex code to achieve what you want, or waiting for the programmers on your team to have time to implement what you want to test, you can implement the logic that you need with something like visual scripting, and you can work much more independently and quickly. So this particularly comes in handy for prototyping style events like hackathons and game jams as well. Now, know that Unity Visual Scripting supports every class and struct type, and it includes an API for advanced tasks and customization. So if you're a programmer and you want your code to be more accessible to non-programmers on your team, you can link visual scripting with your existing C# scripts in your project. You can create custom visual scripting nodes for your team to help them streamline their workflows, and lots more. You can use visual scripting to create not just a single game or application, but you can make templates and tools that you can share with other Unity users, that they can use them as a springboard for their projects or a reference to learn from. Templates are becoming a very popular way that we're seeing visual scripting being used. And lastly, know that visual scripting has existed for many years for Unity. This tool, maybe some of you have heard of it before. It used to be called Bolt before Unity acquired it back in around May 2020. And because it's been in the Unity ecosystem for quite some time, that means it's a pretty wonderfully stable tool. And that means it's ready right now to use in production with Unity versions 2018 and above. So how do you get started with visual scripting? If you are working on a Unity project using Unity 2021.1 and onwards, you don't have to install or worry about a thing. Unity Visual Scripting is built into the editor at this version and onwards. All you need to do to start creating visual scripts is to add a script or state machine component to your game objects, and I'll show you how to do that shortly. Now, if you're using Unity 2018, 2019, or 2020, you'll want to get visual scripting from the Unity Asset Store, which is a marketplace full of different resources that you can add to your Unity projects. It's free to download. You'll just have to search for it. It's called Bolt Visual Scripting. That was the original name of the tool. And when you import it into your project, you get a little setup wizard that walks you through the setup process. And when you're done, no matter what version you may be using of Unity, everything that I'm going to cover from here on out is going to be nearly identical. So let's review the core concepts behind Unity Visual Scripting. You're going to see me reference a couple of things pretty frequently, and I want to clarify what these are. So the first is the building block of a visual script in Unity. It's called a unit. Now, a unit can be some type of action or a way to change a property, but basically it's your basic node element for building visual scripts with visual scripting. Each unit that you work with normally contains two types of inputs and outputs. So the first input, these green arrow inputs that you see here near the top, those are what you connect to establish the flow, the series of events for your units, which are getting activated at which order. Now, you also have these round inputs here, and those can be many different types of inputs, but they all boil down to it's information that the node or the unit needs to execute its action. So, for example, this set velocity unit needs to know a velocity. It needs to receive a velocity to apply to the object that you're working with. And we connect that with little kind of symbols here on the bottom. So with that, a visual scripting unit alone isn't what makes the game work. You have to assemble these units in a graph. And there's two types of graphs in Unity visual scripting. So first, you have a script graph. 90% of the time when you're working with this feature, you're most likely going to use a script graph. And what it is, it's basically a container for your units, and it executes your logic as a linear series of events whenever it is called or triggered or activated. So here we have a very linear set of events. When an object enters my player's trigger collider, we detect what kind of object that is. If it's a door, it's true. Then we set the animation for our character to open the door, and then we destroy, let's say, like a game object in our scene. just a, like basic, like step-by-step flow of events for our game. Now, there's also something called state graphs. State graphs are different sets of behaviors that transition between each other based on certain parameters or things happening in your game environment. So let me use this example of let's say you're doing a game, an ecological game, and you want to create a forest environment and you want to have animals in your world and you want to add AI for the different creatures that you have. And let's say you have a pack of wolves. So to completely overly simplify and insult my zoology background, what kind of states do wolves have, right? They could be hunting, they could be roaming, they could be resting or socializing. Now, these are sets of behaviors that when you open them up, they're actually script graphs, like I showed you earlier. But each state has a specific set of behaviors that apply to the objects that you're working with when that state is active. Now, how do I transition between states? I might create a transition, which are these little bubble kind of arrow flows between the different states. What they do is that they are also basically another type of script graph when you open them up, but you tell that transition to this other state when this specific parameter is met. So let's say I have the wolves in a resting state. I might make a transition that says, okay, when the sun is out in my game, transition the wolves state to the roaming state. And then that transition will happen automatically whenever the sun comes out in my game. And that behavior will constantly run and cycle for the different states of the wolves. So that's a very kind of a general view of state machines. I'm going to jump into an example to show you more because I think it's more fun to just show you how it works in the editor. What I'll do is I will show you a project created with visual scripting. Some elements of it, for the sake of time, will already be completed, but I'm going to show you how to navigate the visual scripting UI. I'm going to show you how to work with different machines and graphs, and I'm going to teach you how to make some basic interactions. So let's go ahead and get started. And if you have any questions at any time, by the way, feel free to add them into the chat or the Q&A. I'll be sure to have some time at the end to answer them. All right, so let's begin with our project. Now here I have the base of a endless runner game. Think something like Flappy Bird. I have our character Penny Pixel here, and what Penny needs to do is jump over obstacles as they appear on the screen. She just jumps into the air and then tries to avoid as many as she can until it's too many obstacles and you hit one and it's game over. Now, what I have already made in this example are the obstacles and how they move. What I need to add is the logic for how Penny moves, and I'll do that with visual scripting. Because right now, if I were to play the game and press anything on my keyboard, nothing would happen. So for an endless runner game, I want to be able to press the space bar to make Penny Pixel here jump in the air. So I'm going to go select my Penny Pixel game object. And I'm going to add a component here in the inspector. The inspector shows me all the different components and basically properties of this game object. She needs a script, so I'm going to add a script machine. Because when you think about that linear series of events, that is going step by step. When we press the space bar, we want her to do an animation and we want her to jump in the air. So when you create either a script or a state machine, you can pick the type of source that you want it to be. You can pick a graph source or an embed source. Now, a graph source saves your visual script as an asset in your project folder. So if I go here, you see I have a couple of different graphs here. Now, when you save it as an asset in your project folder, you can use that visual script again and again on multiple different game objects across multiple scenes in your project. It's a very flexible tool to use. Now, when you are working, let's say when you're working with a visual script and you want to reference multiple game objects in your scene within one single script, then you'll probably want to use an embed graph because that lets you make direct references to other objects in your scene. But let's go ahead and start with a graph. I'm going to hit new to create a new graph asset in my project folder. And I'm going to call this U4H for now. I'll hit save. And it creates for me a brand new visual scripting graph with some template units. Now, whenever you're creating logic and visual scripting, you need certain units to actually activate or tell the script when to start running the logic that you created. These event units are normally marked in green. And for example, there's this start unit, which will run any units that we connect to it when we start our game. We also have the update unit, like I showed you earlier, which will trigger any connected units at every frame of the game on every update. Now, we just want something to happen when we press the space bar, so we don't need these two units. I'm going to select them and delete them. And so I'll have a blank canvas to work with. Now, before I do that, you see here my script machine component, it slightly changed a bit. I now have the ability to add a title and a summary. This doesn't change anything about how the graph logic works, but it lets you keep it organized and make it clear to other folks on your team what this script does, what it's for. So I'm going to call this one player behavior. Now, in this graph, there are two things I want to show you here in the UI. So when you're working with visual scripting, you'll get a graph window, and you'll also get these options for these sub windows here at the top. The first being the blackboard. Now, when you are coding, you are normally working with something called variables. Now, variables are a way to save, store, and reference important data that you're going to need to use throughout your game's lifecycle. Now, there are variables that you can create that apply to just the graph that you're working in. You can have variables that apply to your object overall, variables that apply to your entire scene, your full application across multiple scenes, and even variables that you want to save and retain even after the player leaves the game. So what I want to do here is I'm going to start out, and we're going to reference this later. I'm going to add a variable to Penny to determine what speed she should jump at. So I'm going to click here, new variable name, and I'm going to add a variable called jump strength. I'll hit enter, and it asks me what type of variable do you want this to be? I want it to be a float, a decimal number basically. And I'm going to change that value from 0 to be 8. Now, I think 8 will be a good probably speed for her jump. We'll see when we make that in a bit. But I also want to show you this other very important window for visual scripting, and that's the graph inspector. Now, right now, the graph inspector isn't showing anything because our graph is blank. But let me go ahead and add a unit so that we can see how useful it can be. So I'm going to right click on the background, and that opens up a menu called the Fuzzy Finder. The Fuzzy Finder is your library of all the different visual scripting units that you can work with to create logic for your game. I'm just going to do a test one. I won't use it, I think. Set velocity. Let's see. I put get set. So let's see. All right. So I have this unit here called rigid body set velocity. Now, when I have it selected, look at the graph inspector here. It actually tells me more information about what this unit does. It shows me any specific properties that I could apply to this unit. And it also lets me know what type of inputs it requires and what type of outputs it gives in return. This is very helpful because sometimes you may want to do something with visual scripting and you add a unit and you're not sure if it can achieve what you want. Check the graph inspector to see, okay, if you know that you need a vector 3 output because you want to, let's say, like change the speed of an object, then if I look in the outputs and I see, okay, all right, it's a vector 3 that it outputs, that's exactly what I need for my project. As you are learning, because it takes time, right, to go, like there's a lot of different nodes and there's a lot of different ways to learn how to use them. Definitely use the graph inspector as your guide. Now with that, I'm going to close the graph inspector and delete this unit. And we're going to go ahead and get started creating logic for Penny Pixel for her to be able to jump. So with that, what I'm going to do is I'm going to, let's see, I'm going to add a on keyboard enter unit to keep this very simple. On keyboard input. And what I wanted so that when we press the space key and hold it down, she flies into the air. So when the spacebar key is on hold, like when it's being held, I want to create a vector 2, which is going to give us the coordinates for her jump, essentially, because we're not going to have Penny run left and right here on the screen. We just want her to jump up and down in the air. So I'm going to add a create vector 2 xy unit here. Now, notice if I deselect my units, you see that one of my units is lit up because that's a starting event unit, so it's going to be active. But my other units that I may add, like for example, I'll need to add a get velocity unit this time. Get velocity 2D because it's a 2D game. Now, they aren't showing, and that's because when you have the dim option selected here in visual scripting, which I find very helpful, it lets you know, hey, nothing is connected to this unit. It won't run if you try to execute your visual script. So we know that we have to connect it to other units in our graph. Now we want to get the x velocity of Penny because that's not going to change at all in this game. So we're going to get that from the velocity, get x. And we're going to plug that into the x value here of our create node. Now we're going to also connect our on keyboard input to this vector2 create node. And then we're also going to go back to our Blackboard and use these little kind of line icon here to drag out our jump strength variable and add it as a unit in our graph so that we can reference it for our jump strength. So when we press the space bar, we're going to create a new coordinate based on the player's current X position and the jump strength variable, which is 8 for us. We're going to then apply this vector 2 to our character's velocity. So set velocity, let's see, 2D, there we go. And I'm going to take this vector 2, and I can see here I have an output for vector 2, and this set velocity requires that vector 2. I'm going to connect them. This here, when you see it normally says this, that's what game object is this unit targeting. Now, because this is on our player character, we're just going to leave it alone as this, so it applies to this game object, Penny. Now, once that's set, the last thing we want to do is we want her to do her jumping animation, so it looks like she's actually jumping into the air. So with that, I'll add animator set bool, and the animator, this is a whole other talk, right? But know that Penny has different animations already applied to her game object. And we're going to use these parameters to trigger these animations. So going to my scene view here, I'm going to call this, I'm going to reference the jumping animation. And whenever we press the space bar, I want jumping to be true. So she does that animation. Now with that, we can go ahead and jump into play mode to test this out. I'll hit play. And now that it's loaded all our units and it's much faster for the next time, now we're in our game view and I can go ahead and press space. And now we see Penny jumps in the air. Now her animation doesn't return to walking because we haven't added the units to do that yet. But as I'm pressing the space bar, we can see her jumping as I'm holding it down. She's flying in the air. And that's already a core mechanic for our game that's done in 1, 2, 3, 4, 5, 6, 7 nodes. So I'm going to get out of play mode. And I'm going to add 2 more units so that her jumping animation is reset to her walking one when we're done. I don't even have to type all these nodes over again. I can just select the ones I want to work with, control click, control C to copy. I'm going to go ahead and paste these down here. I'll connect them together, but this time, when the space bar is let go on up, we're going to turn off the jumping animation. So now we can go back. I'll put this here so we could see it easily in our graph. I'm going to go back to play mode because I want to show you one of my kind of most favorite aspects of visual scripting. And that's being able to view your code in action live as you're testing it. So as I press the space bar, pay attention to the connections between the different units. I'm pressing space and you can actually see the code, like the flow of events flow through the different units. Now, this is a very small graph, so it's very clear and easy to understand where everything is going and why it's happening the way it is. But when you're creating larger visual scripts, you want to understand, where is my logic headed? If, let's say, you're trying to press the space button and it's not happening how you envisioned, you can check the flow of your units and see, it's not completing the flow, but why? Or it's going to this other branch of logic that I have. How come? That helps you debug your project much more quickly. And of course, also, if there's an issue with a specific node or it's missing a certain value, then visual scripting will actually highlight that node for you and say, hey, this is missing some information, or you need to fix this unit before you can use this graph successfully. So it's really helpful in that context as well. Now, I'm really short on time. I want to be able to answer some questions. So I'm going to exit play mode, and I'm going to share this project with all of you so you can actually see and play the final game for yourselves. But before I do that, I'm going to go ahead and, or you know what? I'll go do that now. I'll switch back over to my presentation. And here you can get these links. Here's some really helpful resources if you want to learn visual scripting. If you just want to get more information in general about the feature, check out the info page. If you want to see the full documentation so you could start creating visual scripts of your own, be sure to check out that link as well. We have a forum dedicated for all things visual scripting on the Unity forums, so please stop by there if you have any questions. The visual scripting team themselves often keeps an eye on it. And then lastly, we have a bunch of project samples that have different examples that you can download of how to use visual scripting for different types of games and game mechanics. Now, I'm going to go ahead and open for questions. One thing I want to say, because this is a very frequent question and I wanted to clarify it. You can use Unity visual scripting for all sorts of experiences. I use a 2D game to keep it simple, but you can make it for all sorts of games. You can make visual scripts for VR games, for augmented reality, for non-game projects, for science, based solutions, all different types of interactions that you could think of, because at the end of the day, no matter what you're working on, no matter what cause it's for, no matter what purpose, it's all a series of interactions, right? So with that, I have like 2 minutes. I'm going to answer some questions. Someone's asking, is visual scripting free or paid? Visual scripting is completely for free. No, doesn't matter what version of Unity you're on. This is a fully integrated feature into the Unity engine that we have available for all of you. Let's see. The best strategy to learn this software. How long does it take you to learn Unity visual scripting? It depends. One thing I recommend is to follow a couple of Unity tutorials on Unity Learn before you get started. Because I'll say sometimes you open visual scripting, or if you have no experience with Unity, you might have just watched what I did and said, what is that? What's a trigger? What's a collider? If you take some very basic tutorials, it just takes a couple of hours of your time. Those will give you way more context about how Unity works in general. If you caught Adam's talk earlier, he actually did a great overview of these kind of basic concepts. Now, learning those and then going to start using visual scripting will make your journey and experience a lot easier. And there's also visual scripting tutorials available on Unity Learn as well that you can follow. I highly recommend Clive the Cat's Visual Crypting. It's a crypt dungeon based game, but it's all made with visual scripting. It's a lot of fun, and I recommend that you try it out. Let's see, I might have time for one more question. I'll check the Q&A quickly. Oh my God, so many questions. You know what? I wish I could answer these all, but please feel free. Please email me your questions or tweet at me, Instagram me, whatever, and I'll be sure to get back to you. Thanks for joining, everybody. I hope you have a great rest of your conference.